Hello everybody. So we'll be starting the numericals or problems related to ladder friction. The previous video we went through the steps to solve the problems. See, in all the problems related to ladder friction, you'll be finding either the external force what you apply to the foot of the ladder, or you'll be finding the angle, convenient angle made by the ladder with respect to horizontal, so that the ladder doesn't slip down. So let us go through the first problem, which is our first type, where you find the external force. Where you find the external force, you will be applying this external force P. So let us go through the first problem, or problem number 1. I'll be taking you through the problem number 1. Let us go through the problem. A ladder weighing 250 Newton and length 5 meters. Self weight of ladder is 250 Newtons and length of the ladder is 5 meters. Is placed against a vertical wall as shown in the figure. The coefficient of friction between ladder and wall is 0.2. So mu between ladder and wall is 0.2 and coefficient of friction between ladder and floor is 0.3. So here you have two values for coefficient of friction. In all the previous set of problems, you just had only one value of coefficient of friction, because you have two surfaces here. This is wall and the other one is floor. So coefficient of friction between wall and ladder is 0.2 and coefficient of friction between the floor and ladder is 0.3. So ladder has to support a man weighing 750 Newtons at a distance of 1 meter from the wall. So this 750 Newton is the external load. So which is at a distance of 1 meter from the wall, from 1 meter from the top of the wall. 1 meter from the wall or top of the ladder. So calculate the minimum horizontal force applied at point A in order to prevent the slippage of ladder. So you have to calculate the external force applied at the foot of the ladder, which is applied at A in order to prevent the slippage of ladder. This is the problem. It's the first problem number 1. This is. Now let us follow all the steps properly. So step number 1 is to mark self weight and the external load. So self weight acts vertically downwards. So self weight acts vertically downwards and self weight will be acting exactly at the center of the span. So total span is 5 meters. And self weight will be acting exactly at the center of the span. So self weight will be acting at a distance of 2.5 meters from the bottom and 2.5 meters from the top. So it will be acting exactly at the center and it will be acting vertically downwards. Self weight of the ladder is given as 250 Newtons. And once you mark the self weight which moves vertically downwards, you have to extend this so that the line of action of self weight meets the floor. So let me mark this as C, this point as C, where it meets the ground. Next we have to mark the external load as well. External load of 750 Newton is given here. External load of 750 Newton at a distance of 1 meter from the wall. A load of 750 Newton. 750 Newton should also move vertically downwards. And this 750 Newton acts at a distance of 1 meter from the wall in this way. So all the distance what is being given in the question will be the inclined distance. 1 meter from the wall distance. 1 meter from the wall. So this distance will be 4 meters. 4 plus 1 total distance is 5 meters. And self weight acts at a distance of 2.5 meters from the bottom of the ladder and 2.5 meters from the top of the ladder. And this external force acts at a distance of 1 meter from the top of the ladder or 1 meter from the wall. It's not the horizontal distance. 1 meter is not the horizontal distance. 1 meter is the inclined distance. Remember this. Always in all the problems related to ladder friction, distance will be inclined. Distance will always be inclined. Now, so once you mark the external force, you have to extend the line of action of external force so that it meets the floor. Let me mark this point as D. And let me mark this point as E. And let me mark this point as F. And let me mark the last point as G. This is E. Done. So we have marked all the points. So step number 1 is done. In step number 1, you have marked the self weight and the external load given, which is a distance of 1 meter from the wall. 1 meter is the inclined distance, not the horizontal one. Step number 1 is done. In step number 2, what you're supposed to do, you have to mark the normal reaction offered by floor and the wall. So whenever a body is in contact with the surface offers a reaction which is called as normal reaction. So here ladder is in contact with the floor and the wall. So I have marked the wall as surface number 2 and the floor as surface number 1, just to mark all the forces associated with these two surfaces. Just to separate, just to differentiate the forces offered by these two surfaces. So surface number 2 is the wall. Surface number 2 is the wall. So wall is in contact with the ladder. Wall is in contact with the ladder at this particular point B. So wall will offer normal reaction on the ladder. Wall will offer normal reaction on the ladder, and normal reaction should always be perpendicular to the surface. Should always be perpendicular to the surface, directed towards the body, and should be acting exactly the point of contact between surface and the body, which is point B. Let me mark this as normal reaction offered by surface number 2. Surface number 2. Let me mark this as N2. N2. Now, even here, ladder is in contact with the floor. Ladder is in contact with the floor. I have marked floor as surface number 1. Surface number 1. So whenever ladder is in contact with the floor, floor offers normal reaction. Floor offers normal reaction on the ladder, and normal reaction should always be perpendicular to the surface, directed towards the body, and it should act exactly at the point of contact, which is A. Let me mark this as normal reaction offered by first surface, N1. N1. So we have marked normal reaction now. Now it's time to mark the frictional resistance. Frictional resistance will always be acting in the direction opposite to the direction of motion of the body. So if the ladder slips down, the trend of motion of ladder with respect to wall will be downwards. Trend of motion of ladder with respect to wall will be downwards. So if the ladder moves downwards, the frictional resistance will be acting upwards. So let me mark this as F1, which is equal to mu into N1. And this should be tangential to the surface, whereas normal reaction should be perpendicular to the surface. Similarly, if the ladder slips down, the trend of motion of ladder is horizontal to the left here, horizontal to the left. So if the trend of motion of ladder is horizontal to the left, then frictional resistance will be acting horizontal to the right. Let me name this as F4. This is F2. This is F2 mu into N2. This is F1 mu into N1. Mu into N1. That. So we have marked the frictional resistance as well. So we have marked all the forces basically. So after marking all the forces, you'll not be drawing the free body diagram. So if you draw the free body diagram, then you bring all the forces to the center, so it becomes a concurrent force system. Here, since you don't draw the free body diagram, it's not a concurrent force system. It's a non-concurrent force system. Since it is a non-concurrent force system, we'll be applying 3 conditions of equilibrium, not 2. So if it is a concurrent force system, we'll be applying only 2 conditions of equilibrium. Since it's a non-concurrent force system, we'll be applying 3 conditions of equilibrium. First condition, summation of Fx equal to 0. Second condition, summation of Fy equal to 0. And third condition is moment either about A or B should be equal to 0. So these are the 3 conditions of equilibrium which you will be applying. So let me apply the first condition of equilibrium. Summation of Fx equal to 0. Summation of Fx equal to 0. Now, go through all the forces which moves in x direction. We have to go through all the forces which moves in x direction. It's horizontal force P, which moves horizontal to the right, so it is positive. Next, minus N2 plus F1 is equal to 0. Let me simplify this. So this becomes P minus N2 plus F1 is mu into N1. F1 is mu into N1. So mu is 0.3. Mu is 0.3 as far as floor is concerned, and 0.2 as far as the vertical surface is concerned. So it is F1, which is mu into N1, which is offered by the floor. So mu will be 0.3 here. Mu will be 0.3. So let me straight away write it as 0.3 into N1 is equal to 0. Let me consider this as equation number 1. You cannot solve this further. Let me consider this as equation number 1. Now equation number 2 of the condition number 2 will be summation of Fy equal to 0. Second condition of the equation. Summation of Fy equal to 0. Let us concentrate on all forces which moves in vertical direction, in y direction. N1 is positive. N1. Then we have minus 250. Then we have minus 750, then we have plus f2, plus f2 is equal to 0. Let me simplify this and write it down. So it will be n1 minus 250 plus 750 will be 1000 minus 1000 plus f2 will be mu into n2. Mu is 0.2 as far as wall is concerned. Mu is 0.2. So plus 0.2 into n2 is equal to 0. Let me consider this as equation number 2. These are the two equations available. Equation number 1 and equation number 2. Now, let me just retain the equations and let me do all other steps. So let me retain equation number 1 and equation number 2. Let me write it separately so that I can go with the third step, step number 3. So equation 1 is P minus N2 plus 0.3 N1. This is equation number 1, and equation number 2 is N1 minus 1000 plus 0.2 N2 is equal to 0. These are the two equations. This is equation number 1 and this is equation number 2. These are the two equations available. Now, let me apply the third condition of equilibrium. Because it is a non-concurrent force system, you have to apply the third condition of equilibrium as well. The third condition of equilibrium is moment either about A or B should be equal to 0. Let me consider A here. So moment about A is equal to 0. Moment about A is equal to 0. So A is this particular point. So since we are considering A, P will not produce any moment because it acts exactly at A, and N1 will not produce any moment because it acts exactly at A, and even F1 will not produce any moment because it is tangential to the surface. So if you draw the line of action of F1 will be tangential so that the line of action passes through A. So P, N1 and F1 will not produce any moment about A. These three forces will not produce. So let us concentrate on this 250 Newton force. Check whether this 250 Newton force produces clockwise or anti-clockwise moment about point A. So it should be clockwise. Line of action is vertical, force moves downwards, and point about which V moment lies in the left-hand side of the line of action. So it should be clockwise. So it is plus 250 into the perpendicular distance from the line of action. See, this is the line of action. And this is point A. So we need the perpendicular distance from the line of action to point A, which is AC here, in this case, AC. This is the perpendicular distance. This is where point A lies, and this should be the perpendicular distance, not AE. No, it's not 2.5. It is AC. This should be the perpendicular distance. That's why we mark all of these points, C, D, G, etc. in order to find the perpendicular distance. So it is 250 into AC. Check whether this force of magnitude 750 newtons produces clockwise or anti-clockwise. It's again clockwise, so plus 750 into AD it will be. Perpendicular distance will be AD. This is the line of action, this is point A, so perpendicular distance will be AD. Done. Now, we are done with these two forces. Check whether this F2, which is mu into N2, mu is 0.2 in this case. 0.2 into N2. So check whether the F2 produces clockwise or anti-clockwise moment. So force moves upwards, and point about which we need moment lies in the left-hand side of the force. And this particular force is tangential to the surface. So it should produce moment in this direction. It is anti-clockwise. Minus 0.2 into N2. Let me write it in this way. Into the perpendicular distance is AG. AG in this case, in this particular case. AG. Now, the next force is N2. Line of action is horizontal in this way. Force moves horizontal to the left, and point about which we need moment lies below the line of action. So it should produce moment in this particular direction, which is again anti-clockwise. Minus N2 into the perpendicular distance is from the line of action to point A. This is the perpendicular distance, which is BG. which is BG is equal to 0. Is equal to 0. So here AD is unknown, AC is unknown, AD is unknown, AG is unknown, and BG is unknown. So we have to find AC, AD, AG, and BG in order to find the value of N2. Now to find the value of AC, AD, AG, and BG, so we'll be using the concept of triangles. We have to consider the triangles now. Consider this triangle, triangle AEC. Triangle AEC. Triangle A, this small right angle triangle. Triangle AEC. We need the value of AC. We need the value of AC. In order to find the value of AC, we can use cosine operation. We can use cosine. Cos 60, we know the angle. So cos 60 is equal to AC, adjacent side by hypotenuse AE. AC by AE. So AC is the distance what we need, and AE is 2.5. AE is 2.5. So therefore, AC is 2.5 cos 60. 2.5 cos 60, or it is 1.25 meters. So perpendicular distance AC is 1.25 meters. 1.25 meters. So we got the value of AC. So similarly, we have to find the value of AD. In order to find the value of AD, consider triangle AFD. Triangle AFD. Triangle AFD. So what is cos 60 in this triangle AFD? So it is AD by AF. AD by AF. So we need the value of AD by AF is 4. This distance is 4. AF is 4. Therefore, AD is equal to 4 cos 60, which is 2 meters. AD is 2 meters. AD is 2 meters. So we need AG similarly, AG and BG. AG and BG, which can be found by considering a single triangle. So the last triangle what you can consider is triangle ABG. Triangle ABG. This is the last triangle, last right angle triangle which you can consider. So in order to find the value of AG is this. In order to find the value of adjacent side AG, we have to use cos operation. So cos 60 will be AG by AB. So AG by AB is 5. Therefore, AG is equal to 5 cos 60, which is 2.5 meters. So AG is 2.5 meters. 2.5 meters. Now, what is BG now? In order to find BG, the same right angle triangle, in the same right angle triangle, you have to use sine function. You have to use sine function in the same right angle triangle. So it will be sine 60. Sine 60 will be opposite side, BG by AB. BG by, we need BG. So BG by AB is 5. So BG will be 5 sine 60, which is 4.33 meters. So BG is 4.33 meters. So this is how you find the perpendicular distance. This is how you find the perpendicular distance. So once you get all of these perpendicular distances, N2 is the only unknown available here. N2 is the only unknown. Substitute all of these perpendicular distances and find the value of N2. You can find the value of N2. Everything is known except N2. So N2 can be found, and by simple calculation you can find the value of N2, and N2 will be equal to 375.26. 375.26 meters. 26. So once you get the value of N2, substitute the value of N2 in equation 2. Substitute the value of N2 in equation 2 to get the value of N1. I love this. So we got the value of N2 by applying or by finding the moment. We got the value of N2. So when we get the value of N2, we have to substitute the value of N2 in equation 2 to get the value of N1. So N1 minus 1000 minus 0.2 into N2 is 375.26 is equal to 0. Therefore, N1 is equal Therefore, N1 is equal to, which is 924.9. 924.94 newtons. So we got the value of N1 as well. Now you have N2, you have N1. Substitute both N2 and N1 in equation 1. Substitute both N2 and N1 in equation 1 to find the value of P finally, which is the main answer which is required. Which is the main answer which is required, which is the 97.77. The main answer required. So this is how you find. This is the external force which is to be applied at the foot of the ladder so that the ladder doesn't slip down. Ladder doesn't slip down. So this is how you solve the problem. So this is the first type where you find the external force. You have one more type. Which is almost same. Which is solved in the same way. It's solved in the same way where you find the angle made by. Angle will not be given. You have to find the angle made by the ladder with respect to horizontal without any external force. So I'll just take you through the problem. I'll not solve it. I'll just show you how exactly the problem is being solved. So this is the problem. A uniform ladder of weight 200 newtons, self-weight 200 Newton, length 4.5 meter, rests on a horizontal ground and leans on rough vertical wall. The coefficient of surface between ladder and floor is 0.4 and coefficient of friction between ladder and wall is 0.2. Again, you have two coefficient of frictions. Weight, when a weight of 900 Newton, this is the external load. Weight is placed on the ladder at a distance of 1.25 meter from the top of the ladder. 1.25 again is the inclined distance from the top of the ladder. Ladder is at a point of sliding. Ladder is about to slide. Now find the angle made by the ladder with respect to horizontal if no horizontal load or force is applied at the foot of the ladder in order to prevent the slip. This is the question. This is the difference. In this particular, the previous problem we went through, we got an external force. We had to apply an external force at the foot of the ladder in order to prevent the slip of the ladder. Here there is no external force. You have to find that convenient angle made by the ladder with respect to horizontal so that the ladder doesn't slip down. This is all about the question. Now let us solve. Let me just take you through the solution as well. I'll not be solving it manually, but I'll be taking you through the solution. Again, the solution remains the same. I mean, you'll be following the same steps as we went through in the previous problem. So again, you have two surfaces here, surface number 1 and surface number 2. Step number 1 is to mark the self weight, which acts exactly at the center. 4.5 is the total span of the ladder, so it will be acting at a distance of 2.25 meters from the bottom and 2.25 meters from the top. You have to extend it and make the line of action of the self weight meet the floor, which meets at C. And similarly, the external load 900 newtons, which acts at a distance of 1.25 meters, which is the inclined distance from the top of the ladder. So we are done with step number 1. In step number 2, you mark N1 and N2. You know how to mark N1 and N2. And in step number 3, you'll be marking the friction resistance. Here, the ladder slips down. When the ladder slips down, the trend of motion with respect to wall is vertically downwards, so frictional force acts vertically upwards. Trend of motion of ladder with respect to the floor is horizontal to the left-hand side, so frictional resistance acts horizontal to the right-hand side. 0.4 is the coefficient of friction mu as far as floor is concerned, and 0.2 is the coefficient of friction as far as the wall is concerned. So these are the steps. Now, if you don't draw the free body diagram, you'll not be drawing the free body diagram. All the forces here are non-concurrent, so you have to apply all the 3 conditions of equilibrium. So applying the first condition of equilibrium, summation of Fx equal to 0, F1 minus N2 is equal to 0. Simplify it and find N2 in terms of N1 and consider this equation number 1. Now, apply the second condition of equilibrium. And with the help of second condition of equilibrium, by substituting 1 into, you can find the value of N1 and N2 straight away here. N1 and N2 straight away, because you don't have an external force, a horizontal force P, which as you had it in the previous case. So just by applying first condition and second condition, you can find the value of N1 and N2 straight away. Now, apply the third condition of equilibrium. The main aim here is to find the value of theta. Apply the third condition. Again, 200 into AC. AC is the perpendicular distance, 900 into AD is the perpendicular distance, 0.2 into, this is F2 into AE, this is N2 into BE is equal to 0. Again, we don't know the value of AC, AD, AE, and BE. Again, consider the triangles to find the value of AC. AC will be 2.25 cos theta. Theta will be unknown here. AE will be 4.5 cos theta, BE is 4.5 sin theta, and AD is 3.25 cos theta. So substitute everything, and separate the terms with cos theta and sin theta. Bring everything to the left hand side and right hand side. Ultimately, tan theta will be this, and theta will be 58.63. So this is how you find the angle. This is how you find the angle. These are the only two types of numericals available under ladder friction. So go through all the problems which have been solved in the notes. I've solved around 4 problems of these two types in the notes. So please go through all the problems, and if you have any doubts, you can contact me anytime. Thank you.